relay. And we have engineer 𝗤𝗏𝗀𝗃𝗏, an accredited renewable energy engineering consultant, and who will be bringing you into the real life implementation. What are the challenges and how we are going to apply your theories into the industry. Then again, we have engineer Prashant Amarasinghe. Engineer Prashant is the CEO of 𝗤𝗏𝗀𝗃𝗏, Hayleys Wind Energy arm. He will be talking about the commercial aspect and the entrepreneurial aspect of the renewable energy engineering. Okay, these experts are going to give you insights from academic to industry and a complete guidance how you become a useful industrialist and also entrepreneur, especially in the renewable energy engineering. Okay, let me explain how this session is organized. Right? Here we have planned to structure this webinar. Firstly, we will take you through the academic part or syllabuses of this renewable energy engineering program under Kingston University, London. Right? Then after that, we will take you to the industry perspective. After getting these academic knowledge, how you apply the technicality or the technical challenges in the industry. Finally, we will take you to the entrepreneurial aspect that will mainly covered by the engineer Prashant. There, how enterprises are looking for the engineers, what kind of capacities, capabilities you need to have will be discussed. Then we will have a Q&A session, that means question and answer session. There, you need to, you can raise your question. You don't have to wait till the end of the session, but while these speeches going on, you can post your question in the Q&A section of your Zoom link. Then after the session, we will open up the forum. Then we will be forwarding this particular question to relevant resource person in our panel. Right. That is the format that the protocol of these webinar we are going to follow. Right. Then let me introduce our keynote speaker here. Our keynote speaker here is Dr. Sahan Soholi. Dr. Sahan Soholi is a senior lecturer at Kingston University, London, and he's a post leader of the MSc in Renewable Energy Engineering. He specializes in solar thermal systems and thermochemical heat storage and waste heat recovery. And also he's an expert with the International Energy Agency Task 67. Dr. Sahan Soholi has helped to advance energy technologies from lab scale innovation to real world applications. His work addresses some of the world's most urgent challenges in energy, climate, and mobility. And it makes a real impact on the global sustainability landscape. Okay, most importantly, I think this is a good news for others that Dr. Sahan Soholi won the Individual Ambitious Value Award at Kingston University People's Award 2025 last week. And our heartiest congratulations, Doctor. And we are very proud of you. And we are very lucky to have you here, right? And
thank you, Professor. Thank you. I appreciate this.
Actually, honestly, I'm not qualified or competent enough to give the full introduction about Dr. Soholi. But I would like to bring something from his LinkedIn, right? With his permission, what he says is, I'm inspired by pioneers who transform energy engineering and scientific innovations. We see where you're heading, right? Where you're heading. And we wish you all the best, your journey, right? And we are so lucky to have the ambitious energy expert with us, Doctor. And now I invite you to take us into deep dive into renewable energy engineering programs delivered at ESOP and awarded by Kingston University London. Over to you, Doctor.
Thank you. Thank you so much, Prasad, for your introduction. I'm very, very pleased to be here. From my side, I do welcome everyone that have joined us today. I'm Dr. Sahand Husuli. I'm a senior lecturer at Kingston University and course leader for renewable energy engineering here at Kingston University in London. My expertise lies in solar thermal technologies, life cycle assessment, building envelopes, and other fields related to the renewable energy, both in system and also in the component scale. And I'm also expert member of the International Energy Agency Task 67, which is focused on compact thermal energy storages. What I'm going to do now, I'm going to share my screen and I'm going to walk you through the structure of the course, what we do deliver, how we deliver, and what you're going to learn during a year program that you're going to have in this course. Yeah. So give me 1 second so I can share my screen. Okay, if that's visible, which I think that it is.
Yes.
Prasad, could you please just confirm this? Yeah?
Yes, yes.
Lovely, thank you so much. So what I'm going to talk about the Renewable Energy Engineering MSc course. So I'm the course leader, as you know, and I'm based in London. I'm a member of the Department of Mechanical Engineering at Kingston University. Here is my email address. If you have any question, please feel free to contact me through the email and I would be more than happy to answer those questions as well. I thought that I could start with a photo that we took actually last May. And this is a site visit that we did with our students based in London. And we went to Westmill Wind Farm, and actually it's a wind and solar farm. And this is a part of the activity that we do offer, and I'm sure that Prasad and his colleagues also do offer industrial site visit as well, because we believe in the bridging the gap between the education and industry. This is a photo that has been taken, as I said, this year with me and all the students, wonderful students that we had in the course. A little bit more about the course. So the course in a detailed way has been mapped basically based on PSRB, Professional Learning Outcome Mapping, following by the 𝗖𝗵𝗍𝗴 suggestion. So as you can see here, there is 18 pillars that have been covered in this field of study, looking at what you have learned during your undergraduate and what you're going to gain in terms of the knowledge during this postgraduate degree, and which could include, but not limited to, the science and the mathematics as an M1, going through the engineering analysis. So we look at problem analysis, analytical tools and techniques, and technical literatures, going to design, sustainability, looking at teamwork, communication. So it's not only about the scientific aspect, but as an engineer, the course has been designed in a way that could lead you to grow your skills and your practices on different aspects that is needed in the industrial sector. What we are proud of as well is that we are equipped the course with the most recent softwares and also hands-on experience. So everything that you're gonna need during the industry, if you're gonna work in any field of renewable energy sector, including solar, wind, fuel cell, hydrogen, design, simulation, or even like broader skills in terms of looking at carbon credits, life cycle assessment, all of those softwares is going to be covered during the course. I will explain more in details what the softwares are, how we're going to use it and where we're going to use them. But just as a recap, we have Polyson for the solar system designs, WindPro for wind farm design, doing all sorts of assessment, including the zone of visual assessment, noise assessments, and shadow flickers, wind energy generation. So it's been covered on that. We're looking at doing a life cycle assessment on services and products through using a well-known industrial-wide software called 𝗣𝗏𝗄𝗵, and we do also offer in the component scale in terms of the design. You're going to learn SolidWorks as well as Siemens NX for the design aspect, and then you're going to take those designs and bring it to the simulation field in ANSYS. We do offer the practical experience as well. All the modules has been designed in a way that you're going to have hands-on experiences, both in solar power technology, solar thermal, solar PVs, wind technologies, and also hydrogen and fuel cell technology. So it's a well-designed, comprehensive course, basically, that gives you all the expertise that you would need in your work environment in the future. This is the structure of the course. So as you can look, we're going to have 6 core modules in the course, including a fuel cell technology, 𝗵𝗱𝗶𝗏, which is 15 credit, 𝗵𝗱𝗶𝗏 as a wind power technology, 𝗵𝗱𝗶𝗏 as a solar power technology, 𝗵𝗱𝗶𝗏, which is mostly focused on use of the software in today's world in the most of the roles, looking at different softwares, how to use them, how to implement them in your practices. As a 30 credit module, 𝗵𝗱𝗶𝗏. And then if you make a decision to do a PhD, we're going to provide you enough knowledge in your course or if you want or planning to do entrepreneurship, innovation, having your own businesses, SMEs, everything is going to be covered on 𝗵𝗱𝗶𝗏, preparing for different routes that you might take after the graduation of the course. This is also a 30 credit core module. And there is also main core module, which is your final year project or dissertation as a 60 credit, which is mostly a practical and relevant to the industries. From the 2 optional modules, you are allowed to take one of the optional modules as you wish, depending on your targets after the graduation and what topic you prefer, which I'm going to discuss here as well. So looking at the structure of the course, so assuming that you're going to be a January 26 intake, which your basically academic year would be 26-27, you're going to start from mid-January your course, which is going to include fuel cell technology and solar power technology as the main modules. On these 2 modules, basically what we are going to take a look at, we're going to take a look at the fundamental of fuel cell and fundamental of solar thermal technologies. So fuel cell is not limited to only the fuel cell, but hydrogen, the storage of the hydrogen, and it's going to be completed by practical lab activity on that. Going to the solar power technology, you're going to be covering basically solar thermal systems, solar PV systems, hybrid system, for instance, PVT collectors, photovoltaic thermal collectors. Going to the storage side of it, in terms of the solar thermal storages, you're going to learn about the most advanced storage technologies, thermochemicals, phase change materials, and also we're going to look at the building envelope, passive and active building designs. And that's going to be basically covering and completing with the lab-based activity, which is going to be again covered on solar thermal and solar PV systems. Those 2 modules will be completed by 𝗵𝗱𝗶𝗏. As I mentioned, it's mostly focused on the software aspect of the course. I'm going to discuss about the software in more details in the next few slides. That teaching block, which is called teaching block 2, will span until around end of April. You're going to have an Easter period and then exam period, and then the second period is going to start, which includes the project period and also teaching block 1. So from mid-May, you're going to be starting by selecting your project topic, starting to work on your project, and that practice is going to go until end of December, with the delivery of the project in early January 2027. So it's a 1-year course, basically, if you're going to do it full time. Teaching block 1, it starts from September, mid-September, and it includes, again, another 60 credit. 𝗤𝗵𝗱 which is going to look at wind power technologies, design of the wind turbines, different aspects of the wind turbines, environmental aspect of it, and also is going to be accomplished by a lab-based activity. We're going to have 𝗤𝗵𝗱 looking at research techniques, how you can do meaningful research, innovation, if you want to have your own business, having your entrepreneurship aspect stronger, and also looking at the sustainability in the wider aspect. You're going to have a chance to pick one of the optional modules, 𝗤𝗵𝗱 Advanced Product Modeling, looking more on the modeling side, and 𝗤𝗵𝗱 Advanced CFD, looking on the modeling and computational fluid dynamics. Overall, you need to have 180 credit on this course, and then that's going to be basically a plan for a compact year if you take the course from January. Speaking of the optional modules, so remember the first slide that I've showed you in terms of the mapping the skills within the different aspect of the course. So if you look at these two charts and make a comparison, you look at that they are quite similar to each other. The only difference is on the left-hand side, it maps through the advanced product modeling route. So if you take the advanced product modeling, the course will be more emphasized on improving your skills in terms of the problem analysis, design, and teamwork. If you take advanced CFD, as the name suggests, so obviously it's going to be more focused on the engineering principles and looking at the problem analysis and analytical tools and techniques. So those aspects, it would be more stronger than the other aspects if you take that optional module and that's optional route. So in terms of the software, so one of the most, if not the main software in the solar system design is the Polyson. It's going to be offered to all the students, and the students going to have chance to work with the software. You're going to learn everything possible that can be done with the software, from solar PV systems, design, assessing the building demand, even including the white goods in the building, electricity, hot water consumption, heating and cooling demand of the building. So you're going to learn how you can insert the data from the customer to the software and come up and propose a system for that demand. It's not limited, as I said, to the solar PV and solar thermal. It goes beyond. We're going to look at heat pump systems, waste heat recovery systems, a storage system like boreholes, as you can see in this image, control units, and also like heat storage tanks and how you can control it, basically. We have also, for instance, covered most recent technologies, like, for instance, if you're going to have a customer that they have electric cars and they are interested to have also electric charging point at their home, you're going to learn actually, for instance, to understand the behavior that they have when they are using the car. For instance, if they use the car only on 2 specific days of the week to commute to work, how you can calculate this in your assessment and your analysis using the software, including, for instance, charging and also discharging of the car. Everything so is going to be covered in this software, in this field, basically. Looking at WindPro, so you're going to have the main, I would say, the main software that has been offered in wind sector, WindPro. You're going to be working on different layout designs, looking at environmental assessment in terms of the regulations, looking at ZVI, zone of visual of influence. So if you have a wind turbine, what would be the impact on the visual influence? Looking at noise assessment, shadow flickers, and energy assessment of the wind farm. So everything is going to be covered. You're going to have access to the software, and you're going to work with the software in details. Every software that you're going to learn is going to be completed by tailored specific video tutorial that I have been working on that. So it's going to be offered to you guys that you can also, again, repeat those activities on your own pace as well after doing the modules as well. The other software that I would like to highlight is 𝗤𝗍 software, one of the leading software in the life cycle assessment. So imagine if you have a process, what would be the environmental impact of that process? So we do have different examples and activities in class. So for instance, if you are planning to produce a mug, a pen, laptop, or any other aspect or any other product, or you are working on services, once you are trying to produce that one, how much is the environmental impact of that production or that offering of the services? So you're going to learn how to do that, which is one of the fields that recently has been picked up with many industries and looking to expert people on this field as well. It's not limited, as I said, to the system level, but we are also focusing on the component level as well. You're going to learn basically two main design softwares, SolidWorks and Siemens NX. So you're going to learn how to design with these two softwares. And then you're going to learn also how to do simulations using ANSYS. One of the things that we are very proud of is that we are not doing only simple simulations on the ANSYS. We are looking at advanced simulations such as proton exchange membrane systems in the fuel cell technology. So you're going to learn how to actually do the simulation on those topics as well. Duration of delivery of the course. So the course has two entries, September and January. So probably you're going to be more interested in January intakes. The full-time course is for 12 months, September to September or January to January, as I explained previously, and then 2 years part-time, which is quite flexible. All the 15 credit modules are delivered in a 1 day per week for 5 weeks, and the 13 credits as a 2 days per week for 5 weeks. It's not only what you're going to learn during the class, during the delivery of the modules by your lecturers. It's mostly also we provide you the full online learning experience. So you're going to have a vast library of the resources to read through, the source books, the videos, the tutorials, the practice sheets. So you're going to get all of those along with the face-to-face learning. So we do offer basically a hybrid blended learning for all the students. Looking at the assessment and regulations, just to recap, lots of students usually have questions. So we do have, so the course has been designed to provide you skills in working on the project. So all the modules, without any exemptions, is going to have a coursework-based assessment method. So on ME 7750, 51, and 52 is mostly working on the lab activity, hands-on experience with the kits that you're going to do. And then on 7753, looking at using the softwares. So designing a wind farm, designing a solar system, and designing a PEM fuel cell. Looking at 7742 is basically looking at more on the research side of the activities, innovation, entrepreneurship. Again, both optional modules is only coursework based. So you're going to come up with the product in ME 744 or come up with the design and doing the simulation on ME 7754. Looking at dissertation, it's going to be 70% your final report, 15% as an interim report, and 15% as your oral presentation after completing your project. You're gonna, after you enroll, you're gonna have access to a dashboard like this, which basically you're gonna be able to see all the modules that you are enrolled with, all the content, all the materials, video tutorials, access to the articles, to the books. So all the learning resources will be available and categorized and ready for you to use during your learning journey. It's not gonna stop here. So we're not gonna be the people that talk. You're going to have a chance to have your course rep. So you're going to select a person from your cohort, and that student will be in close contact with your course leader. And there's going to be a chance for them to discuss with us during the more senior level meetings, raising your concerns, raising your questions, providing a feedback to us about the course. And we continuously monitor those feedbacks from students, trying to improve the course and tailor it for the students' needs and what industry is required. These are some of the core responsibility of the course rep, including, for instance, receiving the feedback from students, as I mentioned, and just giving them to us to embed it in the course and the feedback from those. That should be the end of my presentation. I would be more than happy to take questions whenever Prasad tells me. This is the last image from us in May. It was a sunny day, which is not very common in the UK. Fortunately or unfortunately. So this is one of the few sunny days in the UK that we had the chance to do the site visit, and we took a photo as well. Thank you so much, everyone.
Okay, thank you so much, Dr. Saad. Indeed, it was very insightful and very comprehensive, I would say. because the way you presented the informative, and you had lots of graphics and all that, we could grab all the whole detail in a matter of a few minutes, right? And we don't let you to leave. There'll be so many questions, Doctor. And after conducting two more speeches, I want you to answer some of the questions coming up from the audience, right? Right. Now, we went through the theoretical and academic part, that what sort of areas covered on this particular MSc. Now, the very reason I brought up these industry professionals, right, how you can leverage your education to industry and also to entrepreneurships. Right. For that, I firstly invite engineer 𝗤𝗏𝗀𝗏𝗏𝗏. He's an accredited renewable energy consultant, specializing in sustainable energy solutions and renewable energy implementations in Sri Lanka. Actually, engineer 𝗤𝗏𝗀𝗏𝗏𝗏 is a seasoned professional in Sri Lankan engineering sector, energy sector. He's an electrical engineer graduated from University of Malta. His career spans thermal, wind, and solar technologies. With his leadership roles at 𝗥𝗲𝗏𝗏, he was vice president there, and the engineer from global. There's another organization he gave the leadership. And also he worked with the global giant like Siemens Gamesa Renewable Energy Lanka. Currently, he is heading the operation of the leading renewable energy organization called 𝗬𝗏, based in Singapore. And he's an accredited renewable energy consultant too. And he's contributing to pre-feasibility studies and national renewable initiatives. With extensive experience in project development, operations, and integrated renewable solutions, engineer 𝗤𝗏𝗀𝗏𝗏𝗏 brings valuable industry insight that bridges academic learning and real-world engineering. Engineer 𝗤𝗏𝗀𝗏𝗏𝗏, I know you, since you studied with me at Malta, I remember you soon after your graduation, you joined with energy sector. You gave the leadership to 𝗥𝗲𝗏𝗏𝗏. It's a thermal plant. Thereafter, I have seen that you have been engaging with the energy, I call it's evolution in Sri Lanka, right? Starting from thermal, then the hydro, the solar, wind, you have covered the full landscape of the energy in Sri Lanka. Right. My question for you is, okay, having gone through this kind of a technical program, renewable energy engineering program, and a master student, postgraduate students, when they enter into the industry, real life experiences, what kind of a challenges, technical challenges, other implementation challenges they will come across, and how can they conquer those challenges? Over to you, engineer 𝗤𝗏𝗀𝗏𝗏𝗏.
Yeah, good evening, Prasad. Good evening, everybody. Am I audible?
Yes, yes.
Thank you.
Yeah.
And thanks, Prasad, for the detailed introduction. And yeah, your question is how we convert our theoretical, whatever the course study into practical in the real world. And I went through the course structure Dr. Just explained, and it is a very comprehensive course structure. I think if you follow this course, I don't think you will get any kind of a issue when it's going to be practically implemented. Anyhow, I will just briefly explain what we do in this, whatever we learn from the theory, how we implement in practical way. And whichever the discipline, either whichever the renewable sources, in Sri Lankan context, it's mainly the solar and wind. Now it is coming the storage, and whichever we can take as it's a project, and project has several stages. We'll start from the feasibility study, and then we go for the project development stage and approval, and then we will move into the engineering, where we do the detailed design of the project. Once the detailed design is done, then we move into the procurement side of the project. We do procurement part. Once the procurement part is done, we go for the real construction work, starting from the civil work, then the mechanical, electrical. Once the construction and this part is done, then we move on to the commissioning phase. The project is commissioned. Once the project commission is done, then we'll hand over to the operation. So the operation will go for the renewable projects operation. The project implementation side will be depend on the source. Solar may be 1 year, maximum 1.5 years, and the wind may be another maybe 2 years, and the project operation phase will go for 20 years. Once the operation is done, we can again repower it, or we can decommission in the project. So this is the all total phase of the project, and each and every phase has we have a different challenges. If you start the feasibility study, we are aiming for the higher. If I take as a solar as an example, ground mounted solar, let's say, in high level, the feasibility study, what we see is the project where the project is feasible or not to go forward. So they are at the very beginning stage. If you go to a site, even you can't access this land. It is sometimes it is vegetation. There is no access. So feasibility study, you have to do a lot of assumptions, and you don't know how the terrains look like. You don't have idea. You don't know how the soil conditions. So we do a feasibility study with a lot of assumptions, and if the project is feasible, financially feasible, then we go for the project development stage, where these if you specifically talking about the solar, there is a different approval process in Sri Lanka, starting from the Sustainable Energy Authority. We have to get the provisional approvals, energy permit, and power purchase agreement. In between, you have to get the environmental approvals, and environmental approval with different government departments approvals, like NBRO, NRMC, and Padise Sabha, and different approvals are there. So this approval stage, you have a different kind of challenges, which is not maybe it is not taught in the academic, but you have to deal with different government organizations, and you have to prepare reports and applications and align with this application requirements. So these are different kind of challenges in the real life. Once your project the feasibility is done, the approvals are ready, then only you are going for the real the detailed design phase. And I forgot to tell that the approval stage, you have to get the finance also arranged. You have to have your project equity capital, as well as the lending. You have to go for bank for the lending part. So you have to have good financial feasibility report of the project. Then we have to move into the real design phase of the project, real engineering phase. So the feasibility studies, we don't know how the site looks. We have a very rough idea of the site. And the real engineering design phase, now you can go to the site and you do the site clearing. And once the site clearing is done, And maybe the feasibility study, you have lay out the panel in a very nice way in the flat terrain. But if you clear the site, you may be surprised. Maybe you have a different slope and terrain, and the soil condition is, you assume, different way. But if you do the real soil testing, you get different surprises. And at the same time, and you have to do a topological analysis, and then your panel layout, what was there in the feasibility, is maybe entirely different. So this can be a real challenge. If you are lucky, you have a flat terrain, no issue. If there is a very slope terrain, then even though you have studied the PVC system in your engineer, I mean the academic level, you have to struggle with civil engineering, how to do the panel layout, and how the filing is to be done, and how the uh, drain system, you have to have a proper drain system, and you have to get the NBRO approvals, whether if it is a slope, there can be landslide. You have to ensure that there is no landslide in that land. So you have to do a slope analysis. So what I want to say is that you get different stage of the project, different challenges. So that is the engineering part. Then your MSc course will equip with you so many academic to how to detail design. The PVCs. I saw that PVCs is in there in the course, so that you can easily design the system with the PVCs. And then you have to go for procurement. So that Sri Lankan context, when you go to procurement, most of the material you have to import. For example, PV module, inverters, transformers. If you ask everything, you have to import. So that you have to familiar with the local the incentive. The government is providing some incentive when you import the material. There is a facility called bonded warehouse facilities. There you can import material so that you can avoid custom duty as well as the taxes. So that your cost will be if you are to incur this cost, your cost will be around 30-40% higher than the what you import. So that you have to get that facility. You have to have some idea about these facilities when you go into that level, procurement level. At the same time, you have to deal with not only you have to procure material, you have to procure the service like contractors. So especially when you are doing local contracts, you have to familiar with the contracts norms and the terms, and then you have to have a proper contract with each and every service providers, so that your demand is, your interest is served. So the SEDA contracts, now in Sri Lankan context, the SEDA contracts, if you are familiar with the SEDA contracts, it's an advantage to you. So the once you complete the procurement part and the construction phase, then we will start the construction phase. Construction phase is the real work is happening on the ground. So you will start with the civil construction, and maybe the piling, maybe first you have to land leveling, sloping, and grading, whatever the things you have to do as per your design. And if you unlucky, if you are to do the civil construction during the rain season, uh, then you have a different challenge. So solar projects, when real construction happen, you have to complete within 4 months, very short time period. You have to complete the project. You will get immense pressure from the investor, because he has started to lending the money from the bank, so that he want to complete the project very short period, so that he can earn, he can earn some money. So you will get immense pressure from the vendor, either it's rain or not. you have to complete that part within a given time period. So you have to have a contingency arrangement if you are in the rainy season. This is happening for the wind projects also. If you do a wind project erection part during high wind season, then a different challenge on that wind side also. Because you can't do the erection part with the high wind condition. Certain wind speed, you can't leave the blades and those things. So that challenge is there in the at the erection phase of this. Then once the civil work is done, then you have the electrical installation, mechanical and electrical installation. So if you have the good contractors, now the Sri Lankan context, we have the solar side. I think there are a lot of contract teams. You can have resources are available, but wind sector, it's still I mean, for the Sri Lanka, it's a new. I mean, we have some experienced team. It's a limited, so we have a lot of potential in wind sector for this area as well. So if you have a good contractors and you have good contract in place, you don't have any issue with the electrical or that erection phase. Then it's the commissioning phase. What we do in the commissioning, so we are connecting the project. I mean, you are connecting your system into the national grid. So once you connect system into, I mean, electrical power generation unit to a national grid, you have to be familiar with the grid code. It is available grid code is available in the web. You can download it and you can go through it. Different requirement is there. Now the requirement become stringent because we are connecting more renewable sources into grid. Then utilities having lot of challenges to manage all these renewables, so that they are putting lot of stringent requirement. So we have to be familiar with all these requirement. Otherwise, or if you implement the project and everything is done last moment, if you have a surprise, that will be an issue. So that familiarizing with the grid code will help you to go to the next phase. Once you commission the project, then you can hand over to the operation team. Then operation will go for 20 years. If it is a solar, you have a different requirement for solar operation. There are also, we need engineers not to the operation phase. You have to do the preventive maintenance and corrective maintenance, and at the same times now you have to do the performance improvement of the project. Now we have the price pressure from the utility everywhere. All the projects, we are going with the low cost version. I mean, the price pressure is there. Then there we need the real engineering to improve the performance. Now if you are equipped with, you have the knowledge with all those areas, so definitely your education knowledge will be helpful if you are in operation phase to optimize avoid the breakdown and optimize the performance, especially the generation. So that is the money. That is where the money is coming. So you can improve the generation and avoid breakdown. So that is operation phase. That will go for 20 years. So that is the life cycle of the project. So what I can briefly, if I summarize this, and I went through the course content of the MSc, that course content. It's a very comprehensive context, and if you go through this 1 year course, it will give you everything. I saw that the solar most we use PVCs for the simulation, and the wind side you have the WindNet Pro, and so it will be also useful, so that I think you can easily do with certain different level of experience, the feasibility studies of the any kind of project. So that will be helpful. And I went through the different life cycle of the project. So there are some challenges. Some challenges I did not highlight it, and one thing I forgot to tell, then all these phase of the project, one important aspect is the safety. So you have to learn the safety and quality of all phase of the project. Safety is my Siemens. I have worked for Siemens for 5 years. In Siemens career, their main focus is the safety. If something, I mean, if any incident or near miss, if you don't want to wait for the accident to happen, if some near miss happens, they will do detailed investigation onto that. Their motto is like now most of the Sri Lankan context we say that safety first, but their motto is zero harm, meaning that. Meaning that everybody come to work has to go as safely back to home. So that is their motto. So we have to make some we have to have a prioritize the safety also in this project side life cycle. So that is my summary. Prasad, any questions? I am happy to take.
Thank you so much, Engineer 𝗖𝗍. I think we saw something beyond the university setup, that when we study the programs, when you step into real life, real ground, right? Things can be totally different scenarios, so different challenges. And thank you so much for sharing your knowledge, experiences. Thanks a lot. And there may be a few more questions for you. Please stay with us. Okay?
Sure.
Okay.
Sure.
Now it's a turn to Engineer 𝗏𝗀 𝗓𝗛𝘂. Actually, we learned about the syllabuses, then curriculum. Then we touch on the industry aspect, the implementation aspect. Right? Now it's time to look at the entrepreneurial and the employers aspect. Right? Now we have Engineer 𝗏𝗀 𝗓𝗛𝘂 with us. 𝗏𝗀 𝗓𝗛𝘂 is the CEO of 𝗬𝗏, that the Hayleys wind energy arm, and leading is one of the prominent renewable energy initiative currently. He has over 25 years experience in engineering, construction, sustainable energy, and also he has held senior leadership positions, including managing director at AUA Engineering, director at George Stewart Engineering, and head of electrical engineering at Sierra Construction, where he led major infrastructure projects. He's a graduate from University of Molotov, specialized in mechanical engineering. He is widely recognized for his contribution to infrastructure growth and renewable energy development in Sri Lanka. Engineer 𝗏𝗀, you are known to me since my university times. Right? I know you are having an entrepreneurial mindset even during the university time.
Yes.
Now you are heading the 𝗬𝗏, that is wind energy arm of one of our oldest conglomerate in Sri Lanka, that is Hayleys, right? If I go back a few years, you all started a solar energy arm,
Yes.
Hayleys Fentons Solar. Now you're giving the leadership to wind energy arm, 𝗬𝗏, right? Okay, from an entrepreneurial and commercial perspective, I want your feedback, right? I want to ask you from why your organizations are interested in renewables now. That is my first question. The second one, actually, what is your organization currently doing to capture this, right? Exactly what sort of things you are engaged with. And thirdly, what do you expect from the renewable energy graduates? Because here we have potential students for our renewable energy engineering master program. This would be interesting for them. They might be in search what kind of opportunities available you all are ready to offer to them. Over to you, Engineer Prashant Amarasinghe.
Yeah, thank you, Prasad, for your introduction. And good afternoon, all distinguished panelists and future renewable energy professionals. So I am not well today. So if it's you have to excuse me for any inconvenience. But the thing is, this Indika told almost all the things which I just want to highlight, but I can continue from Indika's points. So it's like this. So Prasad, we as Hayleys and Hayleys Fentons, we see this the energy demand in Sri Lanka, it's increasing, and the cost of fuel, fossil fuel imports, and this impact of all these climate changes and droughts, floods, and coastal erosion and shifting monsoons like this, it's very badly affect to the energy generation in the country. So we thought to diversify our business into wind energy because it's a huge investment. So if we are comparing with these other energy projects, it's basically we want a huge investment. It's investment sensitive. So most of the investors are not in a position to enter to this wind market because of this huge investment. So we thought that as a largest business entity in Sri Lanka, the oldest one, and we have this capacity to enter to this industry and do this huge investment. That's the main thing we enter to this market. And you know, this rising demand of this renewable energy, now we came to an end of this solar energy because of this other issues in the CB grid substations. Because of the capacity, we have no capacity to absorb this solar energy anymore, I think, without developing the existing substation and the transmission lines. But we have potential for the wind solar energy as well if we develop this network system of Ceylon Electricity Board to absorb this energy. And the other thing, so this investment point of view, mostly this investment, as Indika told, this goes to foreign countries because we don't have any of these equipment manufactured in Sri Lanka. So it's a huge challenge because when you consider the Indian market, they have especially this O&M part, that is operation and maintenance part. The India has so many manufacturers and contractors for this particular industry, the wind industry. But in Sri Lanka, it's growing. Actually, it's not. It's a new business. So we have to find these suppliers and the manufacturers as well as the contractors from foreign countries, except the civil construction. Civil construction, we have this Sri Lankan contractors to build these foundations as in the 𝗘𝗏𝗏. We have capacity to do the construction part, especially the civil construction. But other than that, this erection of the towers, supply of the towers, and even the maintenance also, we have to hire the foreign professionals. So it's a challenge to us. So and it's a expensive task also. So company like us can do it, and some other companies also, but I can say it's a closed market. So company like us have to come to this scene to protect our energy sector. Otherwise, we are not in a position to maintain and supply the necessary demand to the country. And the business point of it's a stable cash flow in future. So now it's a huge investment. We have no much good profit margins, but in future it's growing. So we can keep a constant, stable, long-term cash flows by doing this kind of projects. And I just want to highlight some of these points, like when we are doing or developing a wind farm or a wind turbines. So we are facing some problems with this data thing, because we don't have good wind data in Sri Lanka. Especially this Met department, they don't record this wind data. So we have few stations which we can collect data, and based on the thing is, as Dr. mentioned, this we use this WindPro software to evaluate all these wind potential. So it will be the most important point of this business. So if we only do the calculations, we can't confirm our income. So that will be a disaster in future. So we have no such data collection centers or data collecting centers. That is a main challenge for us. So another thing, the environmental impact of this thing, especially these bird issues. The people of this country, they have very much concerned about all these things unnecessarily. I would say it's unnecessarily, because before starting this kind of project, normally the clients electricity board, they do a environmental impact analysis and a test and a report. So even though all these communities, they are reluctant to accept all this data and the reports, and they are opposing. So my previous previous months, we were not in a position to even start this soil investigation of these wind farms because of the public protest. And this is I think it's an educational issue. So we have to mainly focus on that. And I trust the future energy graduates, especially these renewable graduates, they are keen on this renewable energy. And they have to trust this renewable energy as a good source to our country. Otherwise, we can't survive with this current education system, because especially we don't like to go for alternatives now. So we basically trust all this hydropower, and people are reluctant to go for renewable energy, as I feel. And your third question, Prasad, is this the graduates,
Graduates.
what do you expect from us is we want these graduates for our construction projects, especially these problem solvers. I can name these positions also, especially for this mainly this analyzing part of this wind energy. We want these R&D people for the wind energy calculations, especially this revenue part. We have to do this R&D people for the analytical with analytical skills. So these graduates, they can they have to work with all these foreign contractors, like turbine suppliers, O&M contractors, consultants, local contractors, and government authorities for the approvals and things like this, and the rural communities at the same time. So these graduates are keen on this task. Otherwise, we are reluctant, because recently we did some interviews. Some of these people, they don't like renewable energy. So how can he work as a engineer in these projects? So likewise, these people, they have to keen on this industry. And this fields like this card analyst, remote monitoring, and integration with this electrical substation people, the things like this, they have to work. So finally, I just want to say that we saw an opportunity to combine commercial visibility, technological innovation, and the national impact of this industry. So as Havin, we welcome these graduates because we want civil engineers, especially electrical engineers for the transmission and coordination works, mechanical engineers, especially for this erection work. Unfortunately, I think we have few people for the erection in mechanical erection engineers for the wind towers, and we have to hire from India, and especially these commissioning engineers. I think few people we have, but they are all engaged in different projects. And after that, we want these environmental impact engineers, environmental engineers who can handle all these stakeholder matters. So I think it's the situation now. Thank you, Prasad.
Yes, thank you so much, Engineer Prashant. I think you gave a clear understanding, right, why Hayleys came into this renewable energy market, and is it a kind of a national task you all are engaged with? Because you have so many other businesses to do, but you all have selected this because there are no other parties who's having these capacities, right?
Yes.
And also very much interested and passionate about your analysis about the graduate requirement, right? That means the attitude, like they have to like what they are going to do, and also they need to have the soft skills as well as hard skills, the dealing with the communities and the dealing with the suppliers, the manufacturers. Okay, I think all in all, this is what industry is expected from y'all if you all complete our renewable energy engineering programs, because there are so many opportunities available, as Engineer Prashant mentioned. Okay. Now, thank you so much, Engineer Prashant. Now it's time to go through your questions, and we'll see how we can answer your question. Based on the time we will answer, we will try to combine some of the question when we are answering, right? Okay, first question comes as these. Dr. Sahan, how do you monitor 𝗖𝗍𝗿 MSc? Can I add a bit before handing over to Dr.
Absolutely, Prasad. Please go ahead.
Actually, how do we deliver this program in Sri Lanka under the 𝗖𝗍𝗿 College of Engineering is we do have an institutional agreement with Kingston University. Under that agreement, there is a portion that 𝗖𝗍𝗿 College of Engineering is supposed to do, and there is accountability that Kingston University is supposed to do, right? Under this agreement, 𝗖𝗍𝗿 College of Engineering only under the scope of 𝗖𝗍𝗿 College of Engineering purview, we do only the delivery part of the program. In place of we do same content prepared by Kingston University London, and the assessment prepared by Kingston University London, examinations conducted by Kingston University London, the same examination, same time, you have to sit in Sri Lanka. And on top of that, the governance structure of the Kingston is extended to 𝗖𝗍𝗿. We do have a high-level meeting called executive board meetings with Kingston. That's for the strategic issues. And we do have something called student voice committee meeting. That means you as students, that Dr. Sahan explained, your representative can participate in the university meetings, Senate meetings. These student voice committee meetings, when you raise your voice, that will propagate up to the university Senate. Right? That's a very clear governance that is stipulated, and you will have the direct access to Kingston University LMS. You will be a Kingston University student. You will be getting a Kingston University student ID, and your offer will be given by Kingston University. Your award will be given by Kingston University. The only part handled by the 𝗖𝗍𝗿 College of Engineering is your commercial, your payment side. That is the only engagement, and the lecturing done by most of our lecturers from state university lecturers, either from 𝗬𝗍 𝗨 𝗪 or 𝗤𝗏 or industry professionals. Dr. Sahan, I think you will endorse me?
Yes. So thank you, Prasad. Very comprehensive piece of information. And just to add, I would say, so a couple of things. So the course has been designed from us at Kingston University with the structure that has been accredited by 𝗞𝗍𝗄. So the course itself is structured, and the delivery learning outcomes of all the modules and making sure that is in the level that is needed in the industries all has been designed at Kingston University in accordance with 𝗖𝗍𝗄𝗱. So the design of the course, as I said, is between the Kingston College and Kingston University, and how we do monitor. So we are in close contact with all the module leaders and course leaders at 𝗖𝗍𝗿 College as well. So every element that has been offered to the students, including the assessments, exams, any other elements, has been checked internally and externally by us. So internally means that, so if there is an assessment that going to be done at 𝗖𝗍𝗿 College that has been gonna go through the internal moderation at 𝗖𝗍𝗿 from another colleague, then it's gonna be sent to us. We're gonna do the internal moderation. Moderation means that we're gonna check that if the assessment meets the criteria, meets the learning outcomes, and then it goes to the external body, a person that is from one other universities in the UK, and they review the assessment with the criteria to making sure that everything is set basically with the expectations. So that's how we do monitor all the assessments, criterias, and in terms of the delivery of the course, as I said, most of the material is common between us and colleagues at ESOF, and you're going to also have access to a wide range of tutorials, videos from what we deliver here as well. Hope that I managed to answer the question in details.
Thank you so much. Thank you so much, Doctor. Then Hasini asked about the what are the job opportunities. I think we have covered that during the session. We will be sharing this recording with you all, right? And is this program based on research or not? Dr. Sahan, I think you can answer.
So the content that we are delivering, it's because all the colleagues that they are working on delivering the content and also looking on the developing the content and the structure for the course, all of us, we are expert in field of the research, so all lectures are inspired by what we do in the field of the research itself. So as a content that you will receiving during the course, everything is up to date, everything in the current, updated to the current standard and the current trends in the industry. But on top of that, when you are gonna go through doing your course, there's a lots of coursework that you need to complete, and the part of that coursework will require you guys to do the comprehensive review, research, and literature review from the recent references. And more importantly, when you're gonna do your final thesis project, it's gonna be purely work on the research. It might be either looking at using the softwares or developing a product or similar aspect as well.
Yeah, and also he is asking about what are the facilities, lab, instrument, technologies you are providing. Okay, I can comment on this. Of course, there's a differentiation at the facilities of the Kingston and facilities at the ESOF College of Engineering. But we do fulfill all the requirement, getting the hiring the different facilities around Sri Lanka, because in Sri Lanka there is no we cannot find one single place comprising all these facilities required for this project, right? Then we do get, I think you have seen these videos at the beginning, how we have conducted all these laboratory experiment with Buhuna University and Jayawardenepura University, and we do have our simulation stuff we do locally carry out, right? We will meet the university requirement, and we we give the same experience that Kingston University students are enjoying. Okay, then there's the next question. What would be the direction of Sri Lankan renewable energy with the latest tariff structure? I think Engineer Prashant and Engineer Indika in a better position to answer this. Any of you all can comment on this?
Yeah. Tariff structure, I don't think it's a surprise, because the ultimate target is to have a lower, I mean, your electricity prices should be a target. The government is targeting to 30% tariff reduction. But so if you are generating power from renewable, it has to be reduced. Otherwise, you can't meet the ultimate target. So the tariff is reduced, but tariff now not reduced. It is now it is going with the tenders. For example, wind. Previous government supposed to give Adani 8.26 US cents per kilowatt hour, and the recent tender is dropped to 3.77. It's a very tough tariff, but I think we can meet these targets with the sourcing of the equipment. Now the trend is like that. There's a global trend. I saw that there is another tender happens in Saudi, and the tariff is 2 cents, 2 US cents, yeah, for kilowatt hour. So that is the trend, price in trend. So this price will reduce with the equipment price. I mean, the equipment price and everything will be reduced, so that we have to be competitive. So this is a challenge, but this is where we need innovation. So especially we have to find out. I mean, we have to, innovate the competitive products and local. We have to do some local value addition, and we have to find out the way of how the erection should be done in optimized way, and we have to find out how the improve the performance. So that is a challenge. I mean, it's a challenge, but it has to happen.
Thank you.
Yeah.
Thank you, Engineer. Okay, I think this is for Dr. Sahan. What is the proportion of PV and thermal is included in the syllabus? Because in Sri Lanka, the PV is most popular, but I know that whoever looking for foreign employment, this thermal is must area. Dr. Sahan, can you comment on this?
Yes. So I think that speaking of the tariff, I just want to mention something that where the tariff is going, I think that all around the world is going to be looking at more diversified kind of offering of the energy. Could be, so most of the governments and the policies looking at diversifying the type of the renewable energy technology that has been offered. And also I think that one of the areas that has been also flagged up is the storage field. So those two areas, I think that would emphasize that we should diversify what has been offered and what we are offering. And this is the reason what we always, every year, we are trying to review the content of the course and trying to update it based on the trend. So in terms of the delivery, I would say the solar power engineering course itself is, the module itself is not 50-50 solar thermal. It's a comprehensive module which includes solar PV, solar thermal, building, envelopes, storage, so everything that, but I would say if you are going to look at generally, like trying to say, is like 50-50. So we do PV and solar thermal with the same emphasis, but I would say not in the means that the content is like half content is PV, half content or focus is solar thermal. We try to even offer the hybrid systems, as I mentioned, in terms of the PVT systems, for instance.
Thank you, Dr. Sahan. Then we will move fast. I have a higher national diploma with over 15 years experience in engineering industry. Can I join this program? Can I briefly answer this? Okay. Of course, we do have provision for experience-based evaluation. For that, ESOFT cannot give any wording on this. What we do is you need to provide your comprehensive CV with the certificates. Then our Kingston University admission tutors, one of the professor or doctor will extensively go through your education and experience. They will recommend something, and there is a provision for you to come with the experience. Right. Then Adani code, I think we answered these questions. Next one, in Sri Lanka renewable market, what are the most demanded jobs? I think Engineer Prashant gave some hints about the jobs available right now. Then Raveen Bandara, how is the nuclear power generation scenario in renewable energy sector? Doctor, can you comment on this? How is the nuclear power generation scenario?
So in our course, we do not cover nuclear energy in our course. We do not cover, and then we do not looking at that aspect because there is a lot of debate in terms of if nuclear is a renewable or not. So we do, as I explained, we do cover solar, wind, fuel cell and hydrogen technologies.
Yeah, in Sri Lankan context, I think it is under evaluation. I don't think it will be materialized. There are a lot of inputs that to happen to implement the nuclear capacity and the safety and so many aspects should be there. So I don't think even what is determined which power plant should come is the long-term least cost long-term generation plan. In CB provide 20 years head least cost long-term generation plan. In that plan also I don't see any nuclear. But what is most important is there is a grid interconnection between Sri Lanka and India. So if that happens, we have a lot of the wind potential that Sri Lanka has is more than Sri Lanka requirement. For example, Sri Lankan the present peak demand is 3 gigawatt approximately, and the wind potential we have onshore within the land around 10 gigawatt and offshore around 50 gigawatt. We have abundance of wind. So if India and Sri Lanka grid interconnected and we can generate with wind with the lower cost, we have a good market within the region.
Okay.
Yeah.
Thanks so much, Engineer Indika. I think we are reaching our timeline. One last question I can answer for this. Faisal asking, okay, after completing this course, can we be referred as sustainable engineers, right? It's like this, that the professional titles given by professional bodies and the councils, right? Then this will be a program will give you a qualifications, right? I think we have to wind up our session now because we have reached 8:30 now. And I will take this opportunity to thank our expert panel here.
Thank you. You're welcome.
Dr. Sahan Hosoli.
Thank you so much, Prasad. I really need to leave. I appreciate everyone. Thanks you for your invitation, and we look forward to see all the students.
Thank you so much.
Thank you, Prasad.
Thank you. Good night.
Good night.
Good evening, everyone. Thank you.
Good night.
And also Engineer Prashant, taking your time here and spending with our new students or potential students or interested party. And also Engineer Indika 𝗖𝗍𝗍𝗏.
Thank you for the opportunity, Prasad.
Thank you so much for being here, and your insight was very valuable, and I think our students will appreciate it very much.
Sure.
And finally, those who join here after your work or while at work, thank you spending time with us. I think still you can get connected with us. You can email us, and also we will share these videos if anyone is interested. And on top of that, I would say a big thank to my organizing team who work hard, materials in this event, who did artworks, who did the scripts and all these arrangement. Thank you very much for making this successful webinar session. Okay, everyone, have a good day and good night. And
good night.
As
good
a
night.
final note, we have 6 MScs coming in this January intake. I think my admin can post that. For these programs, you can register now because university staff is going on Christmas vacation. If you are interested, if your colleagues are interested, you may ask them to forward the applications because registration and payments can be done later, right? We can discuss about those things later, but getting the enrollment, getting the offer letter is the most important part because since the university admission staff going on leave, Christmas vacation from second week of December, right? Make sure you submit your application without regretting the missing the January intake. Okay, have a good day. Thank you very much.